Here is the homework for Algebra 2, 6.7. For question number, right here, B, starting with this was the first homework assignment. They're asking you to find the domain and the range of the function and the inverse domain and the range, and what is the actual inverse relation. So if you think about this, this is y equals x minus 2 quantity squared. This is, if you were to sketch the graph of this, this is a parabola, and it's 2 units to the right. It starts here and it goes like this. So if we looked at this function, the domain is all real numbers, and the range is y is greater than or equal to 0. Since this does not pass the horizontal line test, it's not 1-to-1, its inverse will not be a function, so you'd write no. So how do you find the inverse of this? You're going to switch x and y. You're going to take the square root of both sides. You're going to write plus or minus, and then add 2. Now, since the original was not 1-to-1, you can't write f negative 1 of x. So your answer to the rule for this would be y equals plus or minus root x plus 2. Now, this we have to restrict the domain. We have to write the new domain in the range of your inverse. What you're going to do is switch these around. So this is going to be x is greater than or equal to 0, and your range is going to be all real numbers. For number 9, it says find the inverse of each. The inverse of 1, 0 would be 0, 1. And then 2, 1, you're going to graph 1, 2. And 2, 3, and 3, 4. That's the inverse of this relation. The next one, you're going to graph 2, negative 3, 2, 2, negative 3 is right here. 2, negative 2, 2, negative 1, and 2, 0. And here's your graph. Next one, find the inverse of each function. And is the inverse a function? So, first of all, this is a line. It's linear. Ask yourself, does it pass the horizontal line test? Yes. So its inverse, is the inverse going to be a function? Yes, it is for this one. If you look at whether they are or not, this next one is going to be a parabola. Actually, it's upside down because it's negative 2x. And it does not pass the horizontal line test. It's not 1-to-1, so this will not be. For 17, a parabola does not pass the horizontal line test, so its inverse will not be a function. And this also is a parabola. It will not be a function. So all you have to do to find the inverse is switch x and y. So for this one, x is equal to 2y minus 1. You're going to resolve for y, add 1, and divide everything by 2. So y would equal 1/2 x plus 1/2. Since it does pass the horizontal line test, you would write f negative 1 of x equals 1/2 x plus 1/2. For number 15, you're going to switch x and y around. So x is equal to 5 minus 2y squared. You're going to subtract 5. You're going to divide everything by negative 2. So 1/2 x, and this is a negative 2, this is going to be a negative 1/2, and then plus 5/2 is equal to y squared. Then you're going to take the square root of both sides, and that's where you have your plus or minus the square root of negative 1/2 x plus 5/2 is equal to y. Another reason why its inverse is not a function, see, this is not unique. There's two x values for the y, so it's not a function. So you do not write f negative 1 of x. Same with this one, it's not, the inverse is not going to be a function, so you're just going to go right into x is equal to 3y squared minus 5. Add 5. Divide everything by 3. So you get 1/3 x plus 5/3 is equal to y squared. Then square root both sides, and don't forget plus or minus. And same with this one, you have x is equal to 3y minus 4 squared. You're going to take the square root of both sides. So you get plus or minus root x is equal to 3y minus 4. You're going to add 4, divide by 3. And it's not a function. Okay? Next. They want you to graph the relation and its inverse. Just graphing it. So this should be easy to graph. You begin at -3, and you're going to go up 2 and over 1, up 2 and over 1, up 2 and over 1. Now before I connect these dots, which I would just do very lightly for a second, this is the original. This is f of x. So the inverse of this graph, what you'd have to do is take each of these points. If this is 0, -3, you're going to graph -3, 0. This is 1, -1, -1, 1. This is 2, 1, you're going to graph 1, 2. And this is 3, 3, you're going to graph 3, 3. And here is the inverse. And since the original is a function, we can call this f negative 1x. Next one is a line, but it's going this way. It's a negative slope line. Whoops. So there's the graph y equals -x. So if you were to take all these points and invert them, you're going to get this line right here. Next. Y equals -x squared. This is an upside down parabola. It's going to start at the origin and it goes over 1, down 1, and over 2, down 4. This is not 1-to-1, so its inverse will not be a function. It does not pass the horizontal line test. So how would you do the inverse? Well, if you look at this point right here, this is -2, -4, so you're going to graph, instead of -2, here's your T-chart. Instead of graphing -2, -4, you're going to graph -1, 2, 3, 4, and -2. And then we have -1, -1, which is going to be -1, -1, if you switch these two. 0, 0. This ordered pair is 1, -1, so you're going to graph -1, 1. And you could probably guess what the next point's going to be. This is 2, -4. You're going to graph -4, 2. And here's your graph. And again, this is not a function. Obviously, it does not pass the vertical line test, so you can't write f -1x. And the last one, this is a graph of a parabola shifted 1 unit right. So you're going to go 1 unit right, and you're going to go over 1, up 1, over 2, 1, 2, 3, 4. So we're graphing this relation. And to graph the inverse, so here you have, here's my T-chart. This ordered pair is -1, 4. So we're going to graph 4, -1. This ordered pair is 0, 1. We're going to graph 1, 0, which is right there. And we have 1, 0, you're going to graph 0, 1, which is that. And then we have 2, 1, you're going to graph 1, 2. So this is what you have here. And then this last point, which is 3, 1, 2, 3, 4. You're going to graph 4, 3. 1, 2, 3, 4, 1, 2, 3. Now I'm going to use my yellow highlighter to separate the two. So the yellow is the inverse. Number 30. For each function, we're going to find the inverse and the domain and the range of the function and its inverse and determine whether the inverse is a function. So for this one, you've got y is equal to 3x plus 4. This is a line. And the domain for this is all real numbers. And the range is going to be all real numbers. There's no number that you can't put in here for x or for y. It's the set of all real numbers. It's going from negative infinity to positive infinity and up and down, negative infinity to positive infinity. So, does this pass the horizontal line test? Yes. So, determining whether the inverse will be a function is a yes. The answer to that is going to be yes, it's a function. Now, how do you do the inverse? Well, you switch x and y around. So you have x is equal to 3y plus 4, and resolve this for y. Subtract 4, and then divide by 3. So your inverse is going to be f negative 1 of x is equal to 1/3 x minus 4/3. Now your domain and your range for this is going to, it switches, but since they're both all real numbers, it stays the same, all real numbers. So here's the inverse information, and that's the regular function. For 31, this one is a graph 5 units to the right. So if you were to graph this, you'd be over 5, and it looks like that. We talked about this in class today. So your domain for this is going to be x is greater than or equal to 5, and your range is going to be y is greater than or equal to 0. Now when you switch these x and y around, does this pass the horizontal line test? Yes, so its inverse will be a function. So now to find the function, you switch x and y around. So instead of y equals square root of x minus 5, you have x is equal to the square root of y minus 5. You're going to square both sides, y minus 5, and then add 5. Sorry, I'm off here. Give myself some room here. So y would be equal to, bring this over, and you have x squared plus 5. We can write f negative 1 of x is equal to x squared plus 5. And now the domain and the range are going to switch. So for this, your domain is going to be x is greater than or equal to 0, and your range is going to be y is greater than or equal to 5. For 32, if you look at this graph, it's shifted 7 units to the left. 1, 2, 3, 4, 5, 6, 7. It starts here. So the domain on this is going to be x is greater than or equal to negative 7, and your range is y is greater than or equal to 0. This one passes the horizontal line test again, so yes, its inverse is going to be a function. You're going to switch x and y around. So now you have x is equal to the square root of y plus 7. You're going to square both sides. X squared equals y plus 7 and subtract 7. And write it as f negative 1 of x is equal to x squared minus 7. Now your domain and range are going to switch. So now x is going to be greater than or equal to 0, and y is going to be greater than or equal to negative 7. So your equation is f negative 1 of x is equal to x squared minus 7. Your domain is x is greater than or equal to 0, and y is greater than or equal to negative 7 is your range. And yes, it's a function. For this one, you have to graph y equals 2x squared plus 2. Now for this one, without getting too much into detail. This is going to be a shift 2 units up, and it's just vertically stretched by a factor of 2. Don't worry about the actual graph itself. But I just want to generally sketch this so I see what the domain and the range is. The domain for all parabolas is all real numbers, because there's no number that's going to stop you from squaring it and multiplying it by 2 and adding 2 here. Now your range is going to change. This is shifting your graph 2 units up, so your range is going to be y is greater than or equal to 2. Since this does not pass the horizontal line test, its inverse will not be a function. Okay, the inverse will not be a function. Now how do you find the inverse? You're going to write, instead of y equals, you're going to write x equals 2y squared plus 2. We have to resolve this for y. We're going to subtract 2. We're going to divide everything by 2. So you have 1/2 x minus 1 equals y squared. And then square root both sides, and don't forget you have plus or minus. So y is equal to plus or minus the square root of 1/2 x minus 1. So y is equal to the square root plus or minus 1/2 x minus 1. Now the domain and the range for this are going to switch. The domain is going to be x is greater than or equal to 0. I'm sorry, the domain is going to be x is greater than or equal to 2, and the range is going to be all real numbers. Range is going to be all real numbers. All real numbers. And the last one. Okay, this looks like a parabola. It's shifted 1 unit down, and it's upside down. So it looks like this. It's shifted 1 unit down, right here, and it's upside down. So, again, this does not pass, it's not 1-to-1, does not pass the horizontal line test, so its inverse will not be a function. The domain for this is all real numbers, and the range is going to be y is less than or equal to -1. Now, how do you find the inverse of this? You do, instead of y equals, you're going to have x equals negative y squared plus 1. To get y by itself, subtract 1. I'm going to get rid of that negative, so I'll make this negative x plus 1, so I'm dividing by -1. Then I'm going to take the square root of both sides, and I'm going to get y is equal to plus or minus the square root of negative x plus 1. Again, it's not a function, it's not unique. We have 2 values here for x. Since the original did not pass the horizontal line test, its inverse is not a function. Therefore, I cannot write f -1 of x. I have to leave my answer as y equals plus or minus the square root of negative x plus 1. But I do need to write the domain and the range. So what I do is take my domain and range of my original, and I switch them. My domain is going to be x is less than or equal to -1, and my range is going to be the set of all real numbers. That is the homework for section 6.7.